All right, so looking at 152, we're converting from base 10 to other bases. So to convert from specifically base 10 to another base, the number must be regrouped according to the place value system of the new base. It's done by repeatedly dividing the base 10 number by the new base. At each step, we record the remainder, and the sequence of remainders form the digits of the number in the new base. All right, it's a little wordy, so let's break it down to steps. First thing you do, divide the given base 10 number by the new base using long division. Record the remainder even if it's 0. The first remainder becomes the units digit. All right, so that's the least significant digit of the number in the new base. Take the quotient, divide it again by the new base, record the new remainder, repeat the process, do it over and over again until the quotient becomes 0, and write the remainders in reverse order from last to first. The last remainder recorded becomes the most significant digit. That's because you've divided it the most number of times. All right, so if I have 4 divisions of, let's say, 2, that's equivalent to 2 to the 4th power, so that makes it the most significant out of all the possibilities. All right. So a quick little review on how you find a quotient using long division. All right. Divide the given number. So I'm looking down here. We have the example. I'll do another one kind of with you in a sec. But we divide the given number to get a decimal answer. Then we multiply the divisor with the whole number of the answer, ignoring the decimal value, and then subtract the 2. All right, so we could involve a calculator on this. The different ingredients, the dividend is the thing you're dividing. The divisor is the thing you're dividing it by. And the quotient is the result, and the remainder is whatever is left over. All right, so what we're really doing is we're taking that 26, dividing it by 5. Now, previously, I'm sure, any other instance in which you would have done long division, you probably did it by hand, maybe with the support of a calculator, but not necessarily. So this, we're just going to kind of look at it from a calculator standpoint. All right. So if I take the 26 and divide it by 5, the divisor, I get 5.2. So I drop the remainder, or drop the decimal, I should say, multiply it by the divisor, and get that result of 25, which I then subtract from 26. You're basically seeing how many times 5 goes into 26 evenly, right? It'll go in 5 times, giving you a result of 25. Whatever's left over is your remainder. So a quick side example here. Let's say you have 372, and I'll also do it by 5. All right. So I would want to see how many times 5 goes into 372. Now, if I were doing this by hand, I would say, all right, well, let's just go 2 digits at a time. 37 divided by 5. You could, how many times does 5 go into 37? It goes in 7 times, giving you a result. Let me get rid of that little horizontal there, which I don't need. 7 times 5 gets you 35. With 2 left over, and then you'd bring down the 2 if you remember that. And then you'd see how many times 5 goes into 22, which would be 4 times. Again, multiply, gets you a result of 20. And so I'm looking at a remainder of 2. And the only thing I would be able to do at this point would be to bring down a decimal value, which I'm trying to avoid. So I would just say that this is a remainder of 2. Now, using the calculator to support this, instead of doing all that, which, you're welcome to if you're comfortable with it, I can use our little algorithm here, which is take the 372, divide it by 5, drop the decimal, all right? So that gets you a 74. So drop that decimal, multiply by the divisor, I get 370. Which gets me to the remainder very quickly, right? But, we're using the calculator to support our work here, all right? So if I want to convert to base 5, right? So I'm going to convert 84 to base 5. And the whole process is listed here, but when you type up stuff like this, it can be a little, it could be a little funky. And if we're going to make a table out of it, I don't know, it could be sort of lengthy, right? So I'm just going to do it by hand off on the side here. I'm going to take 84 and I'm going to divide it by 5. All right, I'll use this form of division. What I want is 84 divided by 5 as a quotient and a remainder. Now that I think about it, I'll do it the same way I was doing it before. So 84, I usually do it the other way, but let me see how this looks. So 84 divided by 5. All right, so I take the 84 divided by 5, drop the remainder. That gets me a 16. All right. I'm sorry, I keep saying remainder. I drop the decimal, gets me a 16. And then the 16 times the 5 gets me an 80, which has a remainder of 4. All right. So I have a remainder of 4 for one division of 5. All right. So I'm going to hang on to that remainder of 4. All right. But then I'm going to take that quotient of 16, divide that by 5, same deal, all right? So I could do my 16 divided by 5, gets me a 3.2, drop the decimal, said it right that time, all right, drop the decimal, then multiply 3 times the divisor, which is 5, I get a 15. All right, so I have my other quotient of 3. All right, so I'll highlight that, and I'll show you what ingredients we're going to pull out of this. I'm also going to highlight my remainders as we go, because those actually, as it turns out, those are going to be the important parts of our final answer. Okay. Now I'm going to take 3, so the previous answer, and divide it by 5. All right. 5 is bigger than 3, so it's not going to divide evenly in. Right? It'd have to involve a remainder or fraction. Right? You could do 3 divided by 5 to follow the algorithm. You get 0.6, drop your decimal, it's just 0. Then I would subtract off the 0, which is, well, I'm not subtracting anything, and I get a remainder of 3. All right? So once I get down to a 0, what I'm going to do is take stock of my remainders, whatever they happen to be, and those are going to make up my numerical value in base 5. All right? So taking my remainders from bottom to top, all right? So I'll take the 3, I'll take the 1, and I'll take the 4, and I'll put a little subscript there. Anytime it's not base 10, you want to put a subscript, because if I write down a 3-digit number, anybody looking at it is going to be like, okay, that's 314. But this is actually 314 in base 5, right? And we can check our work if you wanted to by doing, because we know the place values. This is 5 to the 0th, 5 to the 1st, 5 to the 2nd. So this would be the same as saying 3 times 5 to the 2nd plus 1 times 5 to the 1st plus 4 times 5 to the 0th. So 3 times 25 is 75 plus 5 plus 4 is going to get me 84, which is what we started with. All right, and that was 84 in base 10. All right. So that's the series of calculations. Now, since you're using your calculator to support your work, if you wanted to, I'm going to kind of slide this over a little bit. You could do it a little bit in a more streamlined way. I'll leave it up to you which method you prefer. All right, and this is the way I was starting to do it. But if I wanted to, I could take 84 divided by 5. I need a quotient and a remainder. All right, so 84 divided by 5, I'm going to pretend I haven't done the problem yet. that's 16, right? We still have to do this act of figuring out what that remainder is. It's just how you want to approach it would be a little bit different, right? So I can take that 0.8, right, if I wanted to, you know. Sorry, I hit the wrong thing. I lost it, right? So I'm dropping the 0.8 is what I meant to do, right? So I'm at 16, then I would multiply that by 5 and see what the difference was between the 84 and this new number. So it went in evenly 16 times with a remainder of 4. Sorry, lost my train of thought there for a second. All right, then I take my 16, divide it by 5. That's a 3 with the remainder. So 3 times 5, 15, that's a remainder of 1. Then I take my 3, divide it by 5. It should get easier as you go. It doesn't go in evenly, and you would have a remainder of 3. And again, it's only the remainders from bottom to top that I care about. So 314 would be my result in, like I said before, base 5. All right. So that's the shorter way of doing it. It's not for everyone. Whatever makes more sense to you. But the algorithm works no matter what base you're converting to from base 10. All right. So if I'm doing base 16, the only difference between the approach would be I'm dividing by 16 instead of dividing by 5s. But the one thing I have to keep in mind is if I'm doing base 16 or hexadecimal, I have those characters after the number 9. So A for 10, B for 11, and so on. So I got to be careful about that. But I'll show you an example in a couple minutes. You could also use the shortcut division approach. But again, that's kind of what I was talking about before. That is you recognizing, all right, I'm taking the 84, dividing it by 5, all right? So 84 divided by 5, again, gets you the 16 and change. So that's your remainder of 4, all right? So by the same reasoning before, 16 times the 5 gets you an 80. The difference between that is 4. Between the 80 and the 84 is 4. And then you would do it again. And again, this looks like kind of like a 13. These are supposed to be like bracketed off. All right, so that's what it should look like. And then once you get down after your repeated division, once you get down to a 0, then you're good. And in terms of recognizing your units, right, how you know it's the units place, it really is just the number of times that you're dividing by 5. All right, so just kind of going back up here when I did the check, we divided by 5 multiple times in order to get that result, and so that corresponded with, I lost my place. That corresponded with the exponent. All right. If we're converting to base 8, it's the same idea. Like I said, I'll just do it off on the side here. If you want to do it again, quotient remainder table, that's fine. The short method, that's fine too. If you want to do it with the long division, if you think that's more to your liking, then fine. I'll do it that way. That's fine also. So it's up to you. So dividing by 8, I would take the 927, divide it by 8. I get that decimal. So take that decimal, drop it, throw it away. Multiply by your divisor, so 115, so again, this is 115, times the 8 gets you to 920, which gives you a remainder of 7, all right? I then take that 115, divided by 8. That gets me 14. Let me shimmy this down a little bit. A little bit more writing, obviously, this way, but I've found that people sometimes don't really fully follow how we're getting the quotient and the remainder, at least early on. So if you wanted to, you could start off doing it this way, and then when you get a good level of comfort with it, then you can do it in a shorthand approach. That seems reasonable to me. All right. So when I subtract, I get a remainder of 3. So then I'll just kind of carry it on over here. All right. So 8 going into 14. That's only going to happen once. Right. 1 times 8 is 8. This part you probably do by hand. That gets you a 6. And then I take the 1 and divide it by 8. 8 doesn't go into 1 as a whole number. So I will have a remainder of 1. And then I just really, like I said, I catalog my remainders backwards. All right, so starting with the last and working my way to the first, and I'll get 1, 6, 3, 7. All right, and again, these are just different ways of writing it to do the work, whatever you find to be the most comfortable. That's the way you should do it. All right. And so you should be good to tackle the exercises on 152.